So diluting solutions is our theme. We're going to look at the math, and ultimately we're just doing ratios. Whatever the ratio we dilute our solution is the ratio our concentration will drop. It's a little vocabulary and then the formula. So the original solution we're going to call the stock. So hopefully you just learned or you're getting comfortable with making up a primary standard. That is your stock, that is your original. It's always the higher concentration. It can be used to make a diluted solution. That has to be lower because we're going to add more water to it. So I've got a graphic here. The dark bottle is the stock. That would have more solute in it. It's the higher concentration, so the color would be brighter. So this is our stock. This is where it's going. This is our diluted. It's just not diluted yet because it hasn't been filled up. To do the dilution ratio, we're going to take the concentration of the stock, so our concentration of our primary standard, times the volume of the stock that we transfer. So this is the trickiest piece. We don't care how big that stock bottle is. We just care about the size that we move. So the CS is, that would be the concentration of the stock, would come from there. The volume of the stock is coming from this pipette. You need to ignore the total volume of the stock. It's irrelevant. You don't need to know it. You could dilute from the Pacific Ocean. You do not need to know the volume of the Pacific Ocean. You just need to know if you take 10 mils out of the Pacific, that's all you need. So at no point are we ever going to use the total volume we have at the beginning. So the concentration of the stock, volume of the stock, really tells us how many moles we are going to put into the dilute. So that is really a moles, and that's going to equal how many moles we dump into the dilute side. So the concentration of the dilute, so that's going to be the concentration of this new solution times the total volume of the dilute. And that black, C dilute, B dilute, that's moles we have at the end. The blue is the moles we took out. So basically the moles that we took from the stock is going to equal the moles we have in the diluted. That's the heart of this formula. So I'm going to rearrange this for the concentration of the dilute. That's often what we want to know. It's going to be concentration of the stock, volume of the stock divided by the volume of the filled up dilute. And I really want to highlight, I'm going to uncircle it. We really just need to think about that ratio. That ratio is how our concentration is going to change. So if I take 10 mils of stock and put it in 100, we're going to have 10 on the top, 100 on the bottom. 10 over 100 is a 10. So the concentration of the stock is going to be times by 10. You don't always have to use this formula. I hope some of you would just think of the ratio of the dilution and just apply that. Okay. This is not a required formula, but sometimes you need math and some structure, and that will help you solve it. But think of that ratio. So let's look at a math example. We'll try to do it without the equation, and then I'll do it with the calculation. So what is the concentration of a solution made up it's made by diluting 10 milliliters of a 1 mole per liter sodium chloride solution, and it got diluted to 100. So what is the concentration of the solution that's made? This is going to be the concentration, but it's going to be of the dilute because we have to make it. It's coming second. By diluting. So now we're getting the numbers of what we're starting with. We're going to take 10 mils. So this is going to be a volume, and that's the volume of this original solution. We call that the stock, or I call it. It's 1 mole per liter, so that's our concentration of the stock. I didn't tell you how much stock there is because we don't care. There could be a liter, 500 mils, 250. Irrelevant. The final volume is going to be 100. So you want to transfer 10, you want to put 90 mils of water in the volumetric flask to get up to that line. So we'll do the math orally. No need of an equation here, but we'll do it second. So what's going on with our concentration? We started by taking 10 mils, and we're going to put it in 100. So that's a 10 that I mentioned orally a few times. We put 10 in 100, so we've 1/10 the volume. So we should expect 1/10 the concentration. So 1 mole per liter times 1/10 would be 0.1. So that should be our concentration. 0.1, 1/10 of the concentration because of 1/10 of the volume. Let's do the formula, and we should get the same thing. So concentration of stock times volume of stock equals concentration of the dilute times volume of the dilute. I'm going to rearrange this for concentration of dilute. I'm just not going to show all my work or else. Concentration of dilute equals concentration of the stock, volume of the stock, volume of the dilute. 1.0 moles per liter times the 10 mils that was in a pipette divided by the volume of the dilute is 100. The mils cancel, so it doesn't actually matter what volume units you use. You could use mils, you could use liters, make your life easy, just make sure they match. And this comes out to that 1/10 ratio. So that's how you can sort of mentally do dilutions or mathematically calculate the concentration of a diluted solution.